Okay, Subha, can you hear me, Subha?
Yes, sir.
Okay. Yes, in today's class, we will discuss naming of compounds containing functional groups, containing single functional group as well as multi-functional groups. Then how IUPAC name will be given if a compound contains single functional group? Do you know, Sapna? How IUPAC name is given if a compound contains single functional group?
Yes, sir.
Yes. If the compound contains single functional group, then we have to decide longest continuous carbon chain containing functional group. And this chain may or not may be longest chain of the compound, but it must contain functional group. What is criteria of longest chain? In this case, the compound must contain functional group. As naming of compounds containing single functional group, first longest continuous carbon chain containing functional group is selected. This chain may or not may be longest carbon chain of the compound, but it must contain functional group. Always remember, this chain may or not may be longest continuous carbon chain of the compound, but it must contain functional group. For example, in following compound, suppose we are considering this compound. In this compound, longest continuous carbon chain is straight chain. Yes or no, Sapna?
Yes, sir.
This chain contains in all 5 carbon atoms. Which chain? Straight chain. But this chain cannot be selected for IUPAC name of the compound because it does not include functional group. Clear?
Yes, sir.
If compound contains functional group, then we have to select longest continuous carbon chain containing functional group. And in this case, longest continuous carbon chain containing functional group is this curved chain, which contains only 4 carbon atoms. Though longest continuous carbon chain of the compound is straight chain, but it will not be selected for IUPAC naming. Clear? Why straight chain is not selected for IUPAC naming in this case?
Yes, sir.
Because it does not include functional group. Now, if the compound contains single functional group, then we have to first select longest continuous carbon chain containing functional group. And then numbering will be done in such a way that functional group must get lowest possible number. This is the condition. Clear? Subha?
Yes, sir.
If the compound contains single functional group, then we have to select longest continuous carbon chain containing functional group, and numbering of carbon atoms will be done in such a way that functional group must get lowest number. That is, numbering will be done from that end which gives lowest possible number to the functional group. That is where from functional group is nearest. Clear? In this case, numbering will be from here. This will be first carbon, then second, third, fourth, and all other rules will be similar to naming of branched chain alkanes. Yes or no? Sapna?
Yes, sir.
Other rules will be similar to the naming of branched chain alkanes. Clear? Then what will be IUPAC name of this compound? Here longest chain containing functional group is 4 carbon chain, so that word root will be but. There are single bonds between carbon atoms, so that primary what is this? N primary suffix. Primary suffix will be N, and here substituent is 2-ethyl. Ethyl group is present on second carbon. And which carbon?
Second carbon.
Second carbon. Ethyl group is present on second carbon, so that this compound will be 2-ethyl butane 1-ol. Why 1-ol, Sapna?
So because alcohol is present on the first carbon.
Yes, alcoholic group is present on first carbon atom. Clear hai? This is 2-ethyl 1-butanol. Butane 1-ol, it can be written as 1-butanol. Clear? Okay. Yes. Here straight chain is longest continuous carbon chain of the compound, but it doesn't involve functional group. Hence, it will not be selected for IUPAC naming of the compound. The longest continuous carbon chain containing functional group is curved chain. Actually, explanation is same for the previous compound, which was taken in example. Okay. Numbering of carbon atoms in longest continuous carbon chain is done from that end where from functional group is nearest, so that the functional group should get lowest possible number. Okay. Now, for example, in following compound, how this compound will be named? As Sapna.
Yes, sir.
How this compound will be named?
So we'll select the chain which contain aldehyde group.
Yes, aldehyde group is functional group in this case. Okay.
So we'll count from there only, sir.
From right to left.
From right to left, yes, sir.
Right to left. Okay. 1, 2, 3, 4, 5. Now, what will be name of this compound?
So it
First,
will be 3-methyl.
Yes, 3-methyl. Okay.
1-pentanol.
1-pentanol. Pentane 1-ol. Actually, in this case, this position of ol is 1. And there is no need to give the position of aldehyde group. Can you give the reason? This compound may be 3-methyl 1-pentanol or simply 3-methyl pentanol. There is no need to give the position of aldehyde group. Can you give the reason?
So because it is counted in the longest chain. This
Actually, if aldehyde, always remember, if aldehyde group, carboxylic acid group, or cyanide group, these are three. Aldehyde group, CHO group, carboxylic acid group, that is COOH group, and cyanide group, nitrile group, C triple bond N. If they are principal functional group, then they are always counted as number 1. They are always terminal in position and they are numbered 1, so that there is no need to give the position of these functional group if they are principal functional group in the compound. In this case, CHO group is principal functional group, so that there is no need to give the position of CHO group. This compound is simply 3-methyl pentanol. Clear? Yes or no? Subha?
yes, sir.
Okay. Here numbering of carbon atoms is done from right hand because it gives lowest number to the functional group. And which one is functional group in this case? Yes. Name this compound. CH3, CH2, CH3, CH2, CH2, COOH. What will be IUPAC name of this compound? Okay. Afan, right?
Yes, sir.
What will be IUPAC name of this compound, Afan?
4-methyl acid, sir.
Hello?
Yes, sir. My voice was audible, sir.
Okay.
Yeah, 4-methyl acid, sir.
4-methyl hexane 1-oic acid. Here also there is no need to give the position of oic acid. So
Yeah,
that this will
acid.
be 4-methyl hexanoic acid.
Yeah.
Clear?
Yes, sir.
Okay. Yes, what will be name of this compound? Subha. Which one is functional group in this case? Subha. C double bond O. This is ketonic group. Which group? Ketonic group. Clear. And ketonic group is non-terminal in position, and we have to give the position if required. Clear. In this case, ketonic group is functional group, and a compound contains ketonic group as well as bromo as a substituent. Which one will be preferred in numbering? Sapna.
Sir,
Which one will be preferred in numbering?
Sir, ketone group.
Ketone group, functional group. Yes, always remember, if compound contains only substituent, then substituent is preferred in numbering of carbon atoms. Numbering is done in such a way that substituent should get lowest possible number. If compound contains substituents as well as multiple bond, then multiple bonds are preferred in numbering. Numbering is done in such a way that multiple bond must get lowest possible number, no matter substituents get which number, no matter. Clear? If compound contains substituent, multiple bond, as well as functional group, then functional group is preferred in numbering. Numbering is done in such a way that functional group must get lowest possible number, no matter substituent and multiple bonds get which numbers. Clear? Yes or no? Sapna. Then in this case,
sir.
numbering will be done from left to right. 1, 2, 3, 4, 5, 6. What will be name of this compound? Then 5-bromo. Then word root hex, because 6 carbon atoms are there in longest continuous carbon chain. Hex 3-one. That can be written as 5-bromo 3-hexanone. Clear? Sapna.
Yes, sir.
Now, naming of compounds containing more than one functional group. If compound contains more than one functional groups, that is naming of polyfunctional compounds. Now, how naming will be done? Often, if compound contains a number of functional groups, then how IUPAC naming of the compound is done?
Basis of priority table, sir.
Hello?
Yes, sir. Basis of the priority table, sir.
Okay. In this case, we have to decide a principal functional group. If there are many functional groups in the compound, suppose compound contain aldehyde group, ketone group, carboxylic acid group, as well as amide group, there are many functional groups in the compound. Then one of them is selected as principal functional group, and we are not free to select any one of them as principal functional group. Actually, principal functional group is decided based on priority table. Clear? There is a priority table of different functional group. On the basis of this priority table, we decide one of the group as principal functional group, and we prefer this principal functional group in numbering as well as in selecting longest continuous carbon chain. We have to select that chain which contains principal functional group, longest continuous carbon chain containing principal functional group, and then numbering will be done in such a way that principal functional group must get lowest number. And all other rules will be similar as in case of naming of branched chain alkanes. Clear? Yes. If the compound contains 2 or more functional groups, then one of them is selected as principal functional group. Clear? On the basis of priority table. Always remember, we are not free to select any one as principal functional group. We have to select principal functional group based on priority table, and this priority table is actually based on reactivity of different functional groups. Clear? A more reactive functional group gets higher position in priority table. Clear? Yes. On the basis of priority table of different functional groups. The priority table of different functional groups with their respective secondary suffix and prefix are listed here. Yes. Here, functional group, secondary suffix and prefix. Secondary suffix means if it is selected as principal functional group, then what suffix will be used. And if it is not selected as principal functional group, then it will be selected as prefix. It will be named as prefix. Clear? So, in case of different functional group present in organic compounds, principal functional group, which gets highest position in priority table is carboxylic acid group. Which group? Carboxylic acid group. Actually, in some group, sulfonic acid group has been shown above the carboxylic acid group. In some books, it has been shown, but as long as most of the books are concerned, carboxylic acid is considered to be at topmost position of priority table. Clear? Then first position is carboxylic acid group. If it is secondary suffix, that is principal functional group, then secondary suffix used will be oic acid. And if it is prefix, if it is being named as prefix, then prefix used will be carboxy. Which prefix?
Carboxy.
Now, second group is sulfonic acid group, SO3H, sulfonic acid group, second priority. And here, secondary suffix used is sulfonic acid. And if it is named as prefix, then prefix is sulfo. Which prefix is used for SO3H group? Sulfo. Next, COOR, ester group, alkyl carbonate. If it is secondary suffix, then it is named as alkyl carbonate. Alkyl, that is R, and COO, carbonate. Alkyl carbonate, alkyl alkanoate. Not carbonate, alkyl alkanoate. In this format, it is named. Clear? And if it is prefix, then alkoxycarbonyl is used as prefix for ester group. Which prefix is used for ester group? Alkoxycarbonyl. Suppose R is replaced by CH3, then it will be methoxycarbonyl. And if R is replaced by C2H5, then it will be ethoxycarbonyl, and so on. Then COOR group, if it is used as prefix, then prefix will be alkoxycarbonyl. Now, COX, acid halide group. Secondary suffix used for acid halide group is alkanoyl halide. Alkanoyl halide. And prefix used is halocarbonyl. What? Halocarbonyl. This X is halo, CO group is carbonyl group. So that prefix used is halocarbonyl. Now, most important case, acid amide group, CONH2, acid amide group. If it is used as principal functional group, then secondary suffix used for acid amide group is alkanamide. And if it is used as prefix, then prefix used will be carbamoyl. Very important case, carbamoyl. Now, CHO group, aldehyde group, if it is used as principal functional group, then secondary suffix will be al. And if it is being used as prefix, then formyl is used for CHO group. Which prefix is used for CHO group? Sapna?
Formyl.
Formyl, yes. Clear? For ketonic group, C double bond O, secondary suffix used is on. But if it is used as prefix, then prefix used is oxo or keto. You can use both of these two, either oxo or keto. Clear? but you have to follow alphabetical order. If you are using keto, then you have to follow alphabetical order taking K, and if oxo, then you have to follow alphabetical order taking O. You can take either oxo or keto, both are applicable. Yes or no? No. Alcoholic group, if it is principal functional group, then secondary suffix is ol, but if it is being used as prefix, then prefix used is hydroxy. Clear? These are some important functional group and priority table. And based on this priority table, we have to decide one of the group as principal functional group, and we have to decide longest. We have to select longest continuous carbon chain containing principal functional group for naming organic compound containing many functional group. And numbering will be done in such a way that principal functional group must get lowest possible number. Clear? Yes. Now, suppose we are taking example of this compound CH3, CH2, CHOH, CH2, CH2, COOH. How many functional groups are present in this compound, Subha? How many functional groups are present in this compound? That is carboxylic acid group and alcoholic group. These two are functional groups which are present in this compound. Now, of these two, one of the group will be selected as principal functional group. Which will be principal functional group, Sapna?
Sir, carboxylic group.
Carboxylic acid group. Means OH group will be used as prefix. Then what will be IUPAC name of this compound? Numbering will be done from this carbon 1, 2, 3, 4, 5, 6. What will be name of this compound? 4-hydroxy. Clear? 4-hydroxy. Word root will be hex because 6 carbon atoms are in longest continuous carbon chain. Hex, 1 oic acid. Whether there is need to give position of COOH group, Sapna? I have already told that if COOH group, CHO group or cyanide group are present as principal functional group, they are always terminal in position. Their carbon atoms are always numbered 1, so that there is no need to give the position of such functional groups. Then what will be IUPAC name of this compound? That is 4-hydroxy hexanoic acid. This is the correct name. 4-hydroxy hexanoic acid. Clear? Now, what will be IUPAC name of this compound? Okay, Sapna, not often. In this case, how many functional groups are there?
2, sir. C double bond and C double bond ketone, sir. Ketone, sir. Yeah.
Which one will be preferred as principal functional group?
CHO, sir.
CHO group, naturally, yes. Then, which will be longest continuous carbon chain? This chain.
Yeah.
This chain will be longest continuous carbon chain.
Yes, sir.
And what will be IUPAC name of this compound?
2-methyl 4-oxohexanol.
H2-methyl
4-oxohexanol.
4-oxo. Okay. Suppose we are using keto for CO group, then K will be first, will
yes,
come
sir.
first.
Yeah.
Means 4-keto, 2-methyl.
Oxohexanol.
If keto is being used for CO group, then keto will come first and methyl will come later,
yes,
in
sir.
alphabetical order. But if oxo is being used, then methyl will come first and oxo will come later.
Yeah.
Yes or no?
Yes, sir.
In this case, suppose we are using oxo, then 2-methyl S, 4-oxo hexanol. Whether there is any need to give position of ul?
No, sir.
No, because if CHO group is present as principal functional group, its carbon atom is always numbered 1. It is always terminal in position.
Yes,
Clear?
sir.
Then IUPAC name is 2-methyl 4-oxohexanal. Yes or no? Yes. What will be IUPAC name of this compound? Very interesting compound. CH3, CH2, C double bond CH2, then CH, CONH2, CH2, COOH. What will be IUPAC name of this compound? Yes. Actually, this compound contains a number of functional groups. This COH group, CONH2 group, as well as multiple bond. Multiple bond is also there. Which chain will be selected as longest continuous carbon chain? In this case, off on. What is priority?
COOH, sir. Carboxylic acid.
Yes, carboxylic acid is principal functional group. Okay, it's
Yeah.
okay. But in selection of longest continuous carbon chain, what is priority? Priority is actually multiple bond gets priority over substituent.
Yeah.
In this case,
If the
this chain
terminate
is longest continuous carbon chain of the compound.
Yeah.
But it does not involve multiple bond. And we have to involve multiple bond. Clear?
Yes,
because
sir.
multiple bond got priority over
Single bond.
substituent.
Yeah.
If multiple bond is there, then we have to select longest continuous carbon chain containing multiple bond. Clear?
Yes, sir.
In this case, this chain will be selected as longest chain containing principal functional group as well as multiple bond. And this CH2, CH3 will be substituent. Clear? Then what will be IUPAC name of this compound? Now, how many substituents are there? This one is substituent. This is also substituent. What will be name? 3-carbamoyl CONH2 group is named as carbamoyl if it is used as prefix. Yes or no?
Yes, sir.
Always remember, this is carbamoyl.
Yeah.
3-carbamoyl, 4-ethyl. On fourth carbon, there is ethyl group. 4-ethyl. Okay. Then pent, because longest continuous carbon chain contains 5 carbon atoms, word root will be pent. Then position of double bond, 4 in fourth carbon involves double bond, 4 in 1 oleic acid. Clear? Now, it can be written as 4-carbamoyl, 3-carbamoyl, 4-ethyl, 4-pentene, 1 oleic acid. We can add pent and in. That is word root and primary suffix can be added. 4-pentene. This position of in is 4. Clear? 4-pentene, 1 oleic acid. You know, there is no need to give position of oleic acid. If carboxylic acid is principal functional group, we can delete it 1. There is no need to give the position of oleic acid. Then what will be name of this compound? 3-carbamoyl, 4-ethyl, 4-pentene oleic acid. Always remember, this position 4 is for in. It is for double bond, not for carboxylic acid group, because carboxylic acid group is always terminal in position. It cannot be on fourth carbon. Yes or no? If it is principal functional group. Now we will take bond line notations. And trend, in today's trend, usually bond line notations are given for IUPAC naming. Then how you name compound? If bond line notations are given for the compound, suppose this compound is given and you have to name it. How it will be named? What are rules? Sapna. What are rules for bond line notations? In case of bond line notations, always remember, every corner is considered, carbon is considered to be present on every corner as well as on end. end of the line. Here also carbon will be there. Clear? And we have to complete tetravalency of carbon. This carbon will be converted into CH3. This will also be converted into CH3. And this carbon double bond carbon is there, so that these carbon atoms will be attached with one hydrogen atom each. Clear? What is compound? That is CH3, CH, double bond CH, CH3. Yes or no? This compound is actually equivalent to, this triple line stands for equivalent to. This compound can be written as CH3. Here CH3 is there. Then CH, CH3, single bond CH. Then double bond CH. And then CH3. Now what will be IUPAC name of this compound? This is butene. 4 carbon atoms are there in longest chain. But. And a double bond is present on second carbon. Butene or 2-butene. This is the IUPAC name. Yes or no, Sapna?
Yes, sir.
Yes. What will be IUPAC name of this compound? This compound can be written as like this. Suppose here carbon will be written, and this carbon will be in fact CH3 in form of CH3. Here CH, here also CH, here CH2, and then OH. This compound is in fact equivalent to this CH3, single bond CH, double bond CH, then CH2, OH. Now what will be IUPAC name of this compound? Sapna?
So as the longest chain contain 4 carbon, it will be but.
Yes, word root will be but. Okay.
Yes, sir. And double bond is on the second carbon.
Yes.
After second, so it will be butene. And,
yes.
And alcohol group is present on first carbon, so 1 all.
1 all. Whether we can remove this 1 in this case also?
No, sir.
No, because all can be present anywhere in this chain. We have to give the position of all. Clear? This is 2-butene, 1 all. Yes. What will be IUPAC name of this compound? Yes, Afan. How it will be named? Such type of compounds are usually asked in NEET.
Yes, sir.
Very simple compound. Yes.
Yeah.
Which one will be selected as longest chain? In this case, this chain will be selected as longest continuous carbon chain.
Yeah.
Yes or no?
Yes, sir.
Numbering will be from here 1, 2, 3, 4, 5. Yes or no?
Yes, sir.
And there present ethyl group on second carbon and methyl group on fourth carbon and double bond on fourth carbon. Yeah. Then what will be name of this compound? Actually, this compound is actually this compound. CH2, here CH2, double bond CH, this is CH. Then this carbon contains a methyl group, CH3. Then single bond CH2, this one. Then CH, this CH contains ethyl group, CH2, CH3. And then CHO. Clear?
Yes, sir.
Now, this chain will be selected for IUPAC naming. Numbering will be from here 1, 2, 3, 4, 5. Yes or no?
Yeah.
What will be name of this compound?
2-ethyl.
We have to follow alphabetical order in naming substituents. 2-ethyl, 4-methyl, then pent, word root, because 5 carbon atoms are in longest chain. Pent, 4-ene, 1 ul. Whether there is any need to give the position of ul?
No, sir.
No. Then compound's name will be 2-ethyl, 4-methyl, 4-pentenyl. Yes or no?
Yes.
Clear?
Yes, sir.
Okay. What will be IUPAC name of this compound? Very important compound. How it will be named? Afan.
Yes, sir. We want to take that numbering double bond. So multiple bonds are there, sir. So 6 carbons will come, sir.
Yes, this will be
Uh,
first carbon. This one
yeah.
is second, third,
Yeah.
fourth, fifth, and sixth. Yes or
Yeah.
no?
Yes, sir.
Clear?
Yeah.
This is hexane derivative,
Hmm.
and hydroxy group is present on second carbon.
Second position. Yeah.
Methyl group is present on fourth carbon, and double bond. What is position of double bond?
Fourth, sir. Fourth position.
Then what will be name of this compound?
2-hydroxy.
2-hydroxy. We cannot use all for this compound because in this case OH group is present as substituent. It is not principal functional group. Clear?
Yes, sir.
2-hydroxy, 4-methyl, then hex. 4 in S, 1 oic acid. There is no need to give the position of oic acid. Then compound will be 2-hydroxy, 4-methyl, 4-hexenoic acid. Yes or no?
Yes, sir.
This is the fact. If COOH, CHO, or CN groups are present as principal functional group, then carbon atoms are these groups, always carbon number 1. Hence, there is no need to give the position of these groups. Always remember. Yes or no?
Yeah.
Yes. In determining alphabetical order of substituents, the prefixes iso and neo are considered to be the part of the name of the respective alkyl group. Always remember iso and neo. Suppose isopropyl group is there or neobutyl group is there, neopentyl group is there, then iso and neo are considered to be the part of the name of substituent. But secondary and tertiary are not considered to be part of the name of the substituent. Suppose secondary propyl is there, then alphabetical order will be decided from propyl, not from secondary. Clear? Tertiary butyl group is there, then alphabetical order will be decided from butyl, not from tert. Yes or no? This is a fact. In determining alphabetical order of substituents, the prefixes iso and neo are considered to be the part of the name of respective alkyl groups, but secondary and tertiary are not considered to be the part of the name of alkyl groups. Iso and neo alkyl groups, if not substituted further, are allowed to be used as substituent in IUPAC naming of the compound. It means isopropyl group or neobutyl group, neopentyl group, they can be used as substituent if further substitution is not there. If further substitution is there, then what to do? If further substitution is there, then what to do for IUPAC naming? We have to number the branch chain also.
Yes, sir.
Clear? We have to number the branch chain also to give the position of different substituent in branches. Okay? Then IUPAC naming of the organic compounds completed here. Now we will discuss about different types of electronic displacement. Actually, GOC, General Organic Chemistry, is especially based on electronic displacement, different types of electronic displacement which are observed in the compound, which make the compound reactive or non-reactive for a particular type of reaction. You know how many types of electronic displacements are there, or what is electronic displacement often? Now
Yes,
we are
sir,
sharing another slides for electronic displacement. Okay.
Yeah.
Just wait. I will share another slide.
Yes, sir.
Yes. First, we'll discuss about inductive effect. Now, reaction mechanism. Do you know what is meaning of reaction mechanism? Sapna?
Yes, sir.
What is meaning of reaction mechanism?
So how the reaction occur?
Yes. In which steps the reaction is occurring? What are different types of steps which are involved in the reaction? Reaction mechanism. The reaction is nothing but breakage of old bonds and formation of new bonds. This is very popular definition of chemical reaction. You know, Sapna, what is chemical reaction? A reaction is nothing but breakage of old bonds and formation of new bonds. This is a very popular definition of reaction. Reaction mechanism means the sequence or steps by which a reaction occurs. That is, different bonds are broken and formed. What is meaning of reaction mechanism? That is sequence or steps by which a reaction is occurring or different bonds are being broken and formed. In general, in chemical reactions, there is a substrate molecule which is attacked by attacking reagent to form a highly reactive reaction intermediate that reacts further to give final product. This is the overall mechanism. During a chemical reaction, there is a substrate molecule. What is there? In chemical reaction, there will be a substrate molecule which will be attacked by attacking reagent, and after attacking of the attacking reagent, there will be formation of a highly reactive compound, highly reactive species that is called reaction intermediate, and this reaction intermediate will react further to form the final product. This is the overall mechanism. Yes. In chemical reaction, there exists a substrate molecule. Which molecule?
Substrate molecule.
Substrate molecule. This substrate molecule is attacked by attacking reagent. And after attacking of attacking reagent, after attack of attacking reagent on substrate molecule, there is formation of a highly reactive species that is called reaction intermediates. And these reaction intermediates, since they are highly reactive, they react further to give final product. This is the overall reaction mechanism. Clear? Now the question is, why substrate molecule is attacked by attacking reagent? Question is, why substrate molecule is attacked by attacking reagent? Can you give the reason, Sapna? Why substrate is being attacked by attacking reagent? Or why attacking reagent is attacking? Question is, why attacking reagent is attacking? What is reason of its being attacking? Afan?
Sir, due to inductive effect, sir.
Due to?
Inductive effect.
Due to inductive effect? No. Actually, why a person becomes attacking? There are some persons which are very mild, but few persons are very aggressive, very attacking. Do you know what is reason behind this? Why a person becomes attacking? In Indian history,
Favorable condition for unfavorable because of
you know
unfavorable.
about Mahmud Ghaznavi, a very popular character in Indian history who attacked India about 17 times, as we know. Why he is attacking only India? Why not other countries? And especially in India, Somnath temple. Do you know why? Mahmud Ghaznavi attacked India 17 times. And in maximum times, he attacks Somnath temple in Gujarat. He never attacked any temple in Maharashtra or any other temple in South. Why? There will be some reason behind it. Actually, attacking reagent, why they are attacking? They are having some deficiency. Due to deficiency, they become attacking. Why attacking reagents are attacking? What is the answer?
Efficiencies.
They are having some deficiency. And these deficiencies are being fulfilled in substrate molecule, so that they are attacking on substrate molecule. Why Mahmud Ghaznavi attacks on Somnath temple? Because Somnath temple was made up of gold. And Mahmud Ghaznavi needs gold. Yes or no?
Yes, sir.
Yes, sir.
Clear? Now, substrate molecule. Why only substrate molecule? Where attacking reagent is attacking? In fact, in substrate molecule, the that is shortage, or you can say the deficiency of attacking reagent is being fulfilled in substrate molecule. Actually, in substrate molecule, there occurs a number of changes, a number of electronic displacements, which make them eligible to be attacked by attacking reagent. Clear? Yes or no? Now we will study about different types of displacement, different types of electronic displacements which are occurring in substrate molecule. Actually, electronic displacements are being occurred in which molecule? Substrate molecule, which makes them eligible to be attacked by attacking reagent. Clear?
Yes,
and
sir.
why attacking reagent is so attacking? What is reason? Because they are having some deficiency, and these deficiency are being fulfilled in substrate molecules, so that they are attacking on substrate molecule. Now, what are different types of changes which make substrate molecule eligible to be attacked by attacking reagent? This will be studied under the heading electronic displacement. Yes or no? Now, electronic displacement, very important topic. Always remember, this is the backbone of organic chemistry. It will connect entire organic chemistry. Clear? Which topic? Electronic displacement. Actually, in organic chemistry cannot be understood well if you are not knowing about electronic displacement. Electronic displacement, very important topic. Now, electronic displacement, the dislocation of electrons from their original position in a molecule is called electronic displacement. Then what is meaning of electronic displacement? Upon dislocation of electrons from their original position. That is called electronic displacement. And always remember, it may be of following two types. First one is permanent displacement. It operates permanently in the molecule, no matter they are reacting or not. Always remember, permanent displacement always occur in the molecule, no matter molecule is reacting or not. Whether the molecule is reacting or not, no matter, it will operate permanently in molecule. And it may, always remember, very important point, it may increase or decrease the rate of the reaction. Permanent displacement may increase or decrease the rate of reaction, but temporary displacement, they always increase the rate of the reaction. This is basic difference between two.
Yes.
Then first one is permanent displacement. It operates permanently in the molecule, no matter they are reacting or not. It may increase or decrease the rate of the reaction. For example, inductive effect, mesomeric effect, and hyperconjugation. These three are permanent displacement. Clear? These three are permanent electronic displacement, which operate permanently in the molecule, no matter molecule is reacting or not. We will study all these one by one. Clear?
Yes, sir.
Temporary displacement. It comes into being in presence of attacking reagents and always increases the rate of the reaction. With displacement, temporary displacement, it does not operate permanently in the molecule. It operates only at the approach of attacking reagent. When attacking reagent approaches to the substrate molecule, then this displacement starts operating. Then temporary displacement comes into being, comes into action in presence of attacking reagent and always increases the rate of the reaction. For example, inductomeric effect and electromeric effect. These two very important cases which are example of temporary displacement. Clear? It gets reversed or vanished on removal of attacking reagent. If attacking reagent is removed, always remember these effects start operating at the approach of attacking reagent and they get vanished or reversed on removal of attacking reagent. If attacking reagent is removed, this effect will get reversed. Clear? Afan?
Yes, sir.
No. Now we'll discuss about
Yes, sir.
inductive effect. Inductive effect. First important effect, inductive effect. The permanent shifting, always remember, the permanent shifting of sigma electron pair. Always remember these notes, in these notes, each word has been placed by selection. It is not copy of a book. Each word has been placed by selection. Clear? You have to emphasize on each word. Always remember the permanent shifting of sigma electron pair. Do you know what are sigma electron pairs? Sapna? Sigma electron pair, you know single bond is always sigma bond.
Yes, sir.
Electron pair involved in formation of single bond, that is sigma electron pair. The permanent shifting of sigma electron pair of a heteroatomic covalent bond. Which bond? Heteroatomic covalent bond towards more electronegative bonded atom is called inductive effect. This is definition of inductive effect. Yeah. The permanent shifting of sigma electron pair of a heteroatomic covalent bond towards more electronegative bonded atom is called inductive effect. Here, more electronegative atom acquires partial negative charge. Why partial? Why not total charge? Afan?
Electronegativity, sir.
Why partial? Why development of partial charge is there? Why not complete charge development is there? Because there is not complete shifting of electron. There is only slight shifting from its position.
Yeah, due to electron.
Not complete shifting.
Yes, sir.
Here, more electronegative atom acquires partial negative charge, that is represented by delta minus, while the other atom acquires partial positive charge, that is delta plus. Thus, the bond becomes polar. Clear?
Yes, sir. Clear.
Suppose we take this example, C single bond X, where X is more electronegative than carbon. What will happen? Electron pair of CX bond will get shifted towards X because X is more electronegative. It has more tendency to attract electron pair, so that X will acquire partial negative charge, delta minus, and C will acquire partial positive charge, delta plus. That is, this bond will become polar. Means it will have two poles, negative poles as well as positive pole. Bond becomes dipolar. Clear? Now, this inductive effect is not confined to a single bond. It is not confined. It is never confined to a single bond, but it is relayed throughout the carbon chain, no matter how long the carbon chain is. Theoretically, it is relayed throughout the carbon chain. Clear? Yes. Inductive effect is not confined to a single bond, but it is relayed throughout the carbon chain, no matter how long the carbon chain is. It means if carbon chain is from India to America, this effect will be shifted to America. Yes or no? Afan?
Yes, sir.
Yes, theoretically it will be shifted to America, but practically, whether it will be shifted to America?
No, sir.
No. Practically, it becomes very, very weak after third carbon atom. It means theoretically it is shifted throughout the chain, but practically it becomes negligible after third carbon atom. This is not a very strong effect. This is a very weak effect. It involves only slight shifting of electron. Yes. Clear? Inductive effect is not confined to a single bond, but it is relayed throughout the carbon chain, no matter how long the carbon chain is. However, its strength goes on decreasing with increase of distance from the source. As we move away from the source, this one is source in this case, as we move away from the source, effect becomes weaker, and it is represented by increasing number of deltas. Means if more number of deltas are there, means effect is more weaker. Clear?
Yes.
In this case, this one is delta plus, and this carbon, now this carbon carbon bond will also become polar, because after acquiring positive charge, electronegativity of this carbon will become higher, so that it will attract the electron pair of this CC bond. Yes or no?
Yeah.
Clear? So
Yes.
that this carbon will also acquire positive charge, but relatively lesser in amount, so that it is represented by double delta plus. Now, this carbon will be more electronegative than this, so that it will attract the electron pair of this CC bond, and this carbon will also acquire positive charge, but in lesser quantity, that is represented by triple delta plus.
Yeah.
It means as we go away from the source that is which is responsible for polarization, as we go away from the source, the polarity becomes lesser, which is represented by increasing number of deltas. Clear?
Yes, sir.
Yes. Theoretically, very important point. Theoretically, inductive effect is relayed throughout the carbon chain, no matter how long the carbon chain is. But practically, it is a very weak effect. Always remember, it is a very weak effect, and it becomes negligible after third carbon atom. Clear? Sapna,
Yes, sir.
what do you know about inductive effect?
So it is very weak effect.
Yes, theoretically it is relayed throughout the carbon chain, no matter how long the carbon chain is, but practically it becomes
Weak.
negligible after third carbon atom. Clear? And what is inductive effect? How you can define it? The permanent
Shifting of sigma electron pair.
sigma electron pair, not pi electron pair. Always remember, permanent shifting of sigma electron pair of a heteroatomic covalent bond towards more electronegative bonded atom. That is called inductive effect. Now, types of inductive effect. How many types of inductive effect are there? It is the following two types. First one is electron attracting or withdrawing effect. That is called minus pi effect. And second one is electron releasing or repelling effect, which is called plus I effect. Then how many types of inductive effect are there?
Two types.
First one is electron attracting or withdrawing effect, which is called minus I effect. Such atoms or groups which are more electronegative than carbon attracts bonded electron pair towards themselves and away from the carbon chain. Always remember, such atoms or groups which are more electronegative than carbon, attracts electron pair towards themselves, away from carbon chain. Clear?
Yes.
They attract electron pair towards themselves, away from carbon chain. Such groups are called atoms or groups having minus I effect, and this effect is called minus I effect. These atoms or groups are called minus I atoms or groups, and this effect is called minus I effect. Then what is minus I effect, Sapna?
So if atoms more electronegative than carbon,
Okay.
so electrons are they attract electron towards themselves.
They
And away
attract
from
electron
carbon.
toward themselves, away from carbon chain. Okay.
Yes.
Such atoms or groups are called atoms or groups having and they are called minus I atoms or groups, and this effect is called minus I effect. Clear? This is minus I effect. X is more electronegative than carbon. Okay. Now, some important atoms and groups having minus I effect in increasing order are as under. You have to learn it. What is order of minus I effect of different groups? Usually questions are asked from this order. As highest minus I effect is for nitro group. Which group? Nitro. Then sulfonic acid. Nitro group is more than sulfonic acid group. Then amine group. Then nitrile group or cyanide group. Then carboxylic acid group. Then fluorine, chlorine, bromine, iodine. Again methoxy. Then phenyl. Then hydrogen. What is order? You have to learn it. What is order of minus I effect for different groups? Highest minus I effect is shown by
Nitro group.
Nitro group. Then it will be followed by sulfonic acid group.
Sulfonic group.
Then amine group, NH2. Then
cyanide group.
Cyanide group, nitrile group. Again
Carboxylic group.
carboxylic acid,
Fluorine,
chlorine, bromine, iodine, methoxy, then phenyl, then hydrogen. Okay? PDF of these slides you can obtain from chemistryforcompetition.com. Yes, sir? Yes or no, Sapna?
Yes, sir.
Yes, you can obtain PDF from this site, chemistryforcompetition.com. Now, electron releasing or electron repelling effect, plus I effect, very important effect. Such atoms or groups which are less electronegative than carbon release bonded electron pair towards carbon chain away from themselves. In this case, they release electrons away from themselves towards carbon chain. These atoms or groups are called plus I atoms or groups, and this effect is called plus I. Suppose we take this diagram. Y is less electronegative than carbon. Then what will happen? Y will release electron towards carbon chain. Towards carbon chain. Y is releasing electrons towards carbon chain. Clear? Such atoms or groups are called atoms or groups having plus I effect, and this effect is called plus I effect. Clear? In this case, Y will acquire delta positive charge and carbon will acquire delta negative charge. Clear, Afan? Sapna?
Yes, sir.
Clear hai?
Yes, sir.
Okay. Some important groups having plus I effect in decreasing order are as under. कुछ important groups जिनका plus I effect decreasing order में है, सबसे पहले कौन है?
Third butyl.
Tertiary butyl. It is followed by
Isopropyl.
isopropyl. Then
N-propyl.
N-propyl. Then
Ethyl.
and methyl.
Then
Actually, alkyl groups are having plus I effect. Clear है? समझ आ रहा है?
Yes, sir.
तो ये आपने देखा कि इंडक्टिव इफेक्ट जो है क्या होता है, कितने टाइप्स के होते हैं और कौन कौन से ग्रुप्स हैं जो इंडक्टिव इफेक्ट शो करते हैं, और साथ में आपने ये भी देखा कि उनका ऑर्डर क्या है. अब हम बात करेंगे कॉन्सिक्वेंसेस ऑफ इंडक्टिव इफेक्ट का. बहुत ही इंपॉर्टेंट टॉपिक है कॉन्सिक्वेंसेस. कहां कहां पर इंडक्टिव इफेक्ट का हमको कॉन्सिक्वेंस देखने को मिलता है. चलें नेक्स्ट स्लाइड हम शेयर कर दें. सपना?
Yes, sir.
ओके, नेक्स्ट स्लाइड शेयर कर रहा हूं मैं. यस, consequences ऑफ इंडक्टिव इफेक्ट। क्लियर? कहां कहां देखने को मिलता है इंडक्टिव इफेक्ट के कॉन्सिक्वेंस? सपना, पहला है रिलेटिव रिएक्टिविटी ऑफ हेलो अल्केन्स। हेलो अल्केन्स की रिलेटिव रिएक्टिविटी हम डिसाइड कर सकते हैं किसके बेसिस पर?
इंडक्टिव इफेक्ट।
इंडक्टिव इफेक्ट के बेसिस पर। क्लियर है? नाउ रिएक्टिविटी ऑफ हेलो अल्केन्स डिपेंड्स अपॉन पोलैरिटी ऑफ CX बॉन्ड। बहुत ही खास पॉइंट है, खुद अपने आप में एक क्वेश्चन है। आपको कई सारा हेलो अल्केन दे देगा और बोलेगा किसकी रिएक्टिविटी ज्यादा होती है। तो रिएक्टिविटी ऑफ हेलो अल्केन्स डिपेंड्स अपॉन पोलैरिटी ऑफ CX बॉन्ड। ग्रेटर द पोलैरिटी ऑफ CX बॉन्ड, मोर इज रिएक्टिविटी ऑफ रेस्पेक्टिव हेलो अल्केन। यस और नो? क्या देखा आपने? हेलो अल्केन की रिएक्टिविटी CX बॉन्ड के पोलैरिटी पर डिपेंड करती है। CX बॉन्ड जितना ज्यादा पोलर होगा, रिएक्टिविटी उतनी ज्यादा होगी। द रिलेटिव रिएक्टिविटी ऑफ प्राइमरी, सेकेंडरी एंड टर्शियरी हेलो अल्केन्स फॉलोज फॉलोइंग ऑर्डर। क्या ऑर्डर है प्राइमरी, सेकेंडरी और टर्शियरी हेलो अल्केन्स के रिलेटिव रिएक्टिविटी का? सबसे कम रिएक्टिव होगा मिथाइल हैलाइड। दिख रहा CH3X इज लेसर देन, उससे ज्यादा रिएक्टिव कौन होगा? इथाइल हैलाइड CH2CH3 दिख रहा है X, उससे ज्यादा रिएक्टिव आइसोप्रोपाइल हैलाइड दैट इज CH3CH3 देन X, और इस C से एक हाइड्रोजन जुड़ा है, and is lesser than tertiary butyl halide that is CCH3CH3CH3X। क्यों ऐसा हुआ सपना?
यस सर।
क्यों ऐसा हुआ? तो आप देखोगे कि ये CX ग्रुप का जो पोलैरिटी है उसको मिथाइल ग्रुप या एल्काइल ग्रुप का जो प्लस आई इफेक्ट है वो इंक्रीज कर दे रहा है। कैसे? ये देखो, here plus I effect of alkyl groups attached to the carbon bearing halogen atom enhances minus I effect of halogen atom and therefore increases the polarity of CX bond. Thus, tertiary haloalkanes having most polar CX bond are most reactive, while primary haloalkanes having the least polar CX bond are least reactive. Clear? सपना,
yes,
क्या हो रहा है ये देखिए, CX बॉन्ड के इलेक्ट्रॉन को X अपनी ओर खींच रहा है लाइक दिस। क्लियर है? और ये जो मिथाइल ग्रुप का प्लस आई इफेक्ट है उसमें हेल्प कर दिया। X खींच रहा था, मिथाइल ग्रुप ने उसमें क्या कर दिया? हेल्प कर दिया। तो नेचुरली CX बॉन्ड की पोलैरिटी क्या हो जाएगी? बढ़ जाएगी। इस कार्बन से जितने ज्यादा एल्काइल ग्रुप जुड़े होंगे CX बॉन्ड उतना ज्यादा पोलर होगा, और CX बॉन्ड जितना ज्यादा पोलर होगा हेलो अल्केन की रिएक्टिविटी उतनी ज्यादा होगी। क्लियर?
यस सर।
तो हेलो अल्केन की रिएक्टिविटी, यहां से एक क्वेश्चन पूछ सकता है, चारों ऑप्शन दे देगा, व्हिच ऑफ द फॉलोइंग हेलो अल्केन इज द मोस्ट रिएक्टिव? व्हाट विल बी आंसर?
Third butyl halide.
Tertiary butyl halide हेलो अल्केन, tertiary हेलो अल्केन। व्हाट इज रीजन?
Sir, because सारे methyl group enhances the polarity between CX group.
yes. मिथाइल ग्रुप का प्लस आई इफेक्ट हेलोजन के माइनस आई इफेक्ट को इंक्रीज कर रहा है। भाई हेलोजन क्या कर रहा था? खींच रहा था। मिथाइल ग्रुप ने क्या कर दिया? सपोर्ट कर दिया, ले जाओ भाई। ठीक है, तो पोलैरिटी बढ़ नहीं जाएगी CX बॉन्ड की? ऐसा और नो?
यस सर।
ओके, तो ये एक तो रिलेटिव रिएक्टिविटी ऑफ हेलो अल्केन्स डिसाइड करने में इंडक्टिव इफेक्ट का रोल होता है। दूसरा रोल देखिए कहां है, रिलेटिव बेसिक स्ट्रेंथ ऑफ एमाइंस। एमाइंस का रिलेटिव बेसिक स्ट्रेंथ हम डिसाइड कर सकते हैं किसके बेसिस पर? इंडक्टिव इफेक्ट। याद रखना ये सब अपने आप में क्वेश्चंस है नीट के। क्लियर है? पिछला वाला क्वेश्चन में कन्वर्ट हो सकता था, बना लोगे?
जी सर।
रिलेटिव बेसिक स्ट्रेंथ ऑफ एमाइंस, एमाइंस का बेसिक स्ट्रेंथ किसके कारण होता है सपने? देखिए क्या लिखा है, अमोनिया एंड एमाइंस कंटेन ए लोन पेयर ऑफ इलेक्ट्रॉन्स ऑन सेंट्रल नाइट्रोजन एटम एंड देयरफॉर दे बिहेव लाइक लेविस बेस। अमोनिया और एमाइंस किसके समान बिहेव करते हैं?
लोन पेयर ऑफ
लुईस बेस के समान। किसके समान?
लुईस बेस।
लुईस बेस। क्लियर? Basic strength of ammonia and amines depends upon the availability of their lone pair of electrons for protonation. बिल्कुल रट लेना, बेसिक स्ट्रेंथ अमोनिया और एमाइंस का किस पर डिपेंड करता है? Basic strength of ammonia and amines depends upon the availability of their lone pair of electrons for protonation. उनका लोन पेयर कितना इजिली अवेलेबल है फॉर प्रोटोनेशन, उस पर डिपेंड करेगा उनका बेसिक स्ट्रेंथ। लोन पेयर जितना इजिली अवेलेबल होगा फॉर प्रोटोनेशन, यानी प्रोटॉन से जुड़ने के लिए जितना इजिली अवेलेबल होगा, बेसिक स्ट्रेंथ उतना ज्यादा होगा। The greater the availability of lone pair of electrons for protonation, more is the basic strength of amine. For example, methyl amine 1 degree is found to be more basic than ammonia. methyl amine अमोनिया से ज्यादा बेसिक होता है। क्या रीजन है? ये देखिए, आपको बताया गया अमोनिया और एमाइन का बेसिक स्ट्रेंथ किसके कारण है? इनके लोन पेयर के प्रेजेंस के कारण। और ये लोन पेयर प्रोटॉन से जुड़ने के लिए जितना इजिली अवेलेबल होगा, बेसिक स्ट्रेंथ उतना ज्यादा होगा। आप देख सकते हैं अमोनिया में भी कोई भी ऐसा ग्रुप नहीं है जो प्लस आई इफेक्ट एक्सर्ट करता हो, है कोई?
नो सर,
नहीं है। जबकि मिथाइल एमीन में मिथाइल ग्रुप कौन सा इफेक्ट एक्सर्ट कर रहा है? प्लस आई इफेक्ट। ये इलेक्ट्रॉन पेयर को टुवर्ड्स नाइट्रोजन रिलीज कर रहा है। क्या होगा इससे? नाइट्रोजन पर इलेक्ट्रॉन डेंसिटी बढ़ जाएगी, जिसके कारण लोन पेयर की अवेलेबिलिटी बढ़ जाएगी फॉर प्रोटोनेशन। क्लियर? यस और नो?
यस
सपना?
जी सर।
क्या देख रहे हैं? हियर प्लस आई इफेक्ट ऑफ मिथाइल ग्रुप increases electron density on nitrogen atom. नाइट्रोजन एटम पर इलेक्ट्रॉन डेंसिटी इंक्रीज कर रहा है। कौन? मिथाइल ग्रुप का प्लस आई इफेक्ट। प्लस आई इफेक्ट जानते हो ना, इलेक्ट्रॉन को रिलीज करने वाला इफेक्ट। मिथाइल ग्रुप इलेक्ट्रॉन को रिलीज किया टुवर्ड्स नाइट्रोजन, नाइट्रोजन पर इलेक्ट्रॉन डेंसिटी बढ़ गई तो नेचुरली लोन पेयर की अवेलेबिलिटी बढ़ जाएगी। यस और नो? सपना?
जी सर। यस सर।
Yes. Here plus I effect of methyl group increases electron density on nitrogen atom and therefore increases the availability of its lone pair of electrons for protonation. Thus, it increases the basic strength of methyl group. Similarly, dimethylamine having two methyl groups with plus I effect is more basic than methylamine. तो मिथाइलेमीन से कहीं ज्यादा बेसिक कौन होगा?
सेकेंड डाइमिथाइलामीन।
डाइमिथाइलेमीन। रीजन बताओ, क्या रीजन है?
सर दो मिथाइल ग्रुप है उधर,
दो मिथाइल ग्रुप प्लस आई इफेक्ट एक्सर्ट कर रहे होंगे, नेचुरली इलेक्ट्रॉन डेंसिटी पर नाइट्रोजन पर और ज्यादा बढ़ जाएगी। ये देखिए डाइमिथाइलेमीन में दो मिथाइल ग्रुप है जो प्लस आई इफेक्ट एक्सर्ट कर रहे हैं, नाइट्रोजन पर इलेक्ट्रॉन डेंसिटी बढ़ जाएगी, नेचुरली इलेक्ट्रॉन पेयर की अवेलेबिलिटी बढ़ जाएगी फॉर प्रोटोनेशन। यस और नो? So dimethylamine 2 degree amine will be more basic as compared to methyl amine that is 1 degree amine. अब आगे एक एक्सेप्शन आने वाला है, ध्यान देना। On this basis, trimethylamine 3 degree having 3 methyl groups with plus I effect should be the most basic amongst methylamines. यही अगर ट्रेंड रहा तो सबसे ज्यादा बेसिक किसको होना चाहिए?
ट्राइमिथाइलामीन।
However, in practice, it is found to be less basic than dimethyl amine, that is 2 degree, and even lesser basic than methyl amine. Methyl amine से भी कम basic पाया गया है. कौन? 3 degree amine. Can you give the reason, सपना? क्या रीजन है? एक तरफ आप बोल रहे हो मिथाइल एमाइन से ज्यादा बेसिक है डाइमिथाइल एमाइन, क्योंकि 2 मिथाइल ग्रुप आपने ऐड कर दिया जो प्लस आई इफेक्ट एक्सर्ट कर रहे थे, तो आपने देखा कि डाइमिथाइल एमाइन ज्यादा बेसिक हो गया. अब ट्राई इस बेसिस पर तो ट्राई मिथाइल एमाइन को मोस्ट बेसिक होना चाहिए, जबकि मैंने बताया कि वह डाइमिथाइल एमाइन से इवन मिथाइल एमाइन से भी लेस बेसिक. क्या रीजन सपना?
हिंड्रेंस की वजह से सर.
Yes, steric hindrance. Very good. Thus, the relative order of basic strength of ammonia and different methyl amines, याद रखना अभी हम methyl amines की बात कर रहे हैं, is found to be as under. सबसे ज्यादा बेसिक कौन? याद रहे, बहुत ही इंपॉर्टेंट केस है, यूजुअली IIT-JEE और नीट में ये ऑर्डर पूछता है. सबसे ज्यादा बेसिक डाइमिथाइल एमाइन. याद रहे मिथाइल ग्रुप के लिए ये ऑर्डर है, अगर इथाइल ग्रुप लग जाता है, आइसोप्रोपाइल ग्रुप लग जाता है, तो ये ऑर्डर चेंज हो जाएगा. ठीक है, क्योंकि स्टीरिक हिंड्रेंस का एक्सटेंट और साथ में वहां पर प्लस आई इफेक्ट का एक्सटेंट, कई सारे फैक्टर मिलकर के डिसाइड करते हैं रिलेटिव बेसिक स्ट्रेंथ को. तो यहाँ पर मिथाइल ग्रुप जब लगा है उस समय का क्या केस होता है, देखिए डाइमिथाइल एमाइन दैट इज 2 डिग्री is greater than methyl amine that is 1 degree, is greater than trimethylamine that is 3 degree amine, and is greater than ammonia. तो क्या ऑर्डर मिला? 2 degree is greater than 1 degree, is greater than 3 degree, is greater than ammonia. Yes or no? Clear?
Yes sir.
ये ऑर्डर मिलता है. क्यों ऐसा हुआ उसका रीजन देखिए. इनफैक्ट इन ट्राइमिथाइलेमाइन, ड्यू टू द स्टीरिक हिंड्रेंस ऑफ 3 bulky methyl groups, the lone pair of electrons becomes less approachable for proton. Hence, basic strength of trimethylamine, that is 3 degree amine, gets highly reduced and it becomes less basic than dimethylamine, that is 2 degree, and even lesser than methylamine, that is 1 degree. क्या हो रहा है यहाँ पर? ये देखिए, ट्राइमिथाइलेमाइन में 3 भारी भरकम मिथाइल ग्रुप लग गए. What will happen? क्या होगा? अब प्रोटॉन अप्रोच नहीं कर सकता इस लोन पेयर के पास आसानी से, उसको घूम के यहां पहुंचना पड़ेगा. समझ आ रहा है? भारी भरकम एल्काइल ग्रुप यहां लग गए, उससे क्या होगा? मान लीजिए प्रोटॉन यहां है, तो क्या उसको यहां से घूम के यहां पहुंचना पड़ेगा. ये लोन पेयर लेस अप्रोचेबल हो गया, आसानी से प्रोटॉन वहां नहीं पहुंच पा रहा है, तो नेचुरली बेसिक स्ट्रेंथ क्या हो जाएगा?
घट जाएगा सर, कम हो जाएगा, कम हो जाएगा,
डिक्रीज हो जाएगा. तो इस इफेक्ट को कौन सा इफेक्ट बोलते हो आप? स्टीरिक हिंड्रेंस. चलिए, तो ये बेसिक स्ट्रेंथ ऑफ एमाइंस, इसको हमने डिसाइड किया रिलेटिव इंडक्टिव इफेक्ट के बेसिस पर. नेक्स्ट है रिलेटिव एसिडिक स्ट्रेंथ ऑफ कार्बोक्सिलिक एसिड्स. कार्बोक्सिलिक एसिड्स के एसिडिक स्ट्रेंथ को भी हम डिसाइड करते हैं इंडक्टिव इफेक्ट के बेसिस पर. क्या लिखा है? Acidic strength of carboxylic acids depends upon the ease to which they ionize to give proton. कार्बोक्सिलिक एसिड का एसिडिक स्ट्रेंथ किस पर डिपेंड करता है?
सर ease to which they ionize,
आसानी से आयोनाइज होकर प्रोटॉन देता है, कितनी सरलता से आयोनाइज होकर प्रोटॉन देता है, उस पर डिपेंड करता है. तो एसिडिक स्ट्रेंथ ऑफ कार्बोक्सिलिक एसिड्स डिपेंड्स अपॉन ease to which they ionize to give proton. The greater the ease to which an acid ionizes to give proton, more is its acidic strength. कोई एसिड जितना आसानी से आयोनाइज होकर प्रोटॉन देगा, उसका एसिडिक स्ट्रेंथ उतना ही ज्यादा होगा. फॉर एग्जाम्पल, मीथेनोइक एसिड इज फाउंड टू बी मोर एसिडिक देन इथेनोइक एसिड. मीथेनोइक और इथेनोइक एसिड में कौन ज्यादा एसिडिक है? मीथेनोइक एसिड. क्यों ऐसा हुआ? रीजन ये देखिए, यहाँ OH ग्रुप ध्यान देना, ऑक्सीजन इज मोर इलेक्ट्रोनेगेटिव, OH बॉन्ड के इलेक्ट्रॉन को अपनी ओर खींचा, हाइड्रोजन का एज प्रोटॉन रिलीज होना आसान बनाया। लेकिन मिथाइल ग्रुप क्या कर रहा है, प्लस आई इफेक्ट एक्सर्ट कर रहा है। ये इफेक्ट यहाँ एक्सर्ट किया जो आगे रिले हो गया, नेचुरली इस OH बॉन्ड का इलेक्ट्रॉन थोड़ा शिफ्ट हो जाएगा, किधर, टुवर्ड्स हाइड्रोजन। कहने का मतलब ये कि हाइड्रोजन का प्रोटॉन के रूप में रिलीज होना क्या हो जाएगा, डिफिकल्ट हो जाएगा। किसके केस में, सपना, इथेनोइक एसिड के केस में, क्योंकि यहाँ मिथाइल इफेक्ट, मिथाइल ग्रुप का प्लस आई इफेक्ट क्या कर रहा है, कार्बोक्सिलिक एसिड ग्रुप के हाइड्रोजन को प्रोटॉन के रूप में रिलीज होने को डिफिकल्ट बना दे रहा है। तो नेचुरली एसिडिक स्ट्रेंथ को घटा देगा, जबकि इस टाइप का इफेक्ट मिथेनोइक एसिड में एक्सर्ट नहीं हो रहा है। यस और नो? क्या लिखा है हियर, प्लस आई इफेक्ट ऑफ मिथाइल ग्रुप इन इथेनोइक एसिड makes difficult the release of carboxylic hydrogen as proton and therefore decreases the acidic strength of the ethanoic acid. No such effect operates in methanoic acid. Methanoic acid में ऐसा कोई इफेक्ट ऑपरेट नहीं करता। तो which one is more acidic, ethanoic acid or methanoic acid?
Methanoic acid.
सपना,
Methanoic acid.
methanoic acid, yes. आगे देखो, सिमिलरली प्रोपेनोइक एसिड containing ethyl group with more stronger plus I effect. प्रोपेनोइक एसिड में कौन सा ग्रुप होगा, मिथाइल ग्रुप की जगह इथाइल ग्रुप लगेगा वहां, जिसका प्लस आई इफेक्ट ज्यादा स्ट्रॉन्गर है, is in turn less basic than इथेनोइक एसिड। इथेनोइक एसिड से भी कम बेसिक कौन होगा, प्रोपेनोइक एसिड होगा, क्योंकि वहां पर इथाइल ग्रुप जो लगा है उसका प्लस आई इफेक्ट और स्ट्रॉन्गर है, तो नेचुरली एसिडिक स्ट्रेंथ को और घटा देगा। On the other hand, chloroethanoic acid is found to be more acidic than ethanoic acid. क्यों ऐसा हुआ, OH ग्रुप के इलेक्ट्रॉन को ऑक्सीजन खींच रहा था, जो क्लोरीन का माइनस आई इफेक्ट है, क्या किया, इलेक्ट्रॉन को OH मतलब ऑक्सीजन का जो इलेक्ट्रॉन खींचने की क्षमता थी उसको इंक्रीज कर दिया है माइनस आई इफेक्ट में। दिख रहा है कैसे, सपना?
सब बट ऑक्सीजन तो क्लोरीन से भी मतलब ज्यादा,
ऑक्सीजन क्या है,
मोर नेगेटिव देन क्लोरीन है ना।
इस बॉन्ड को ध्यान दो, हाइड्रोजन से ज्यादा इलेक्ट्रोनेगेटिव है ऑक्सीजन, यस और नो?
यस सर।
OH बॉन्ड के इलेक्ट्रॉन को खींचा, और इस Cl और C में कौन ज्यादा इलेक्ट्रोनेगेटिव है, यहाँ देखो Cl इज मोर इलेक्ट्रोनेगेटिव, इट विल अट्रैक्ट इलेक्ट्रॉन, और ये जो इफेक्ट था वो आगे रिले होगा। आ रहा है समझ में? तो ये जो आगे इफेक्ट रिले होगा, एक तरह से ऑक्सीजन के खींचने की क्षमता को इसने क्या कर दिया, क्लोरीन के माइनस आई इफेक्ट ने इंक्रीज कर दिया, जबकि इथेनोइक एसिड में प्लस आई इफेक्ट उस काम को क्या कर रहा था, डिक्रीज कर रहा था, ऑक्सीजन के खींचने की क्षमता को, OH बॉन्ड के इलेक्ट्रॉन को खींचने की क्षमता को डिक्रीज कर रहा था। कौन, मिथाइल को, प्लस आई इफेक्ट वाला ग्रुप। समझ आया?
जी सर।
क्या लिखा है? On the other hand, chloroethanoic acid is found to be more acidic than ethanoic acid. Reason क्या है? Here minus I effect of chlorine atom makes easier the release of carboxylic hydrogen as proton. Carboxylic hydrogen को प्रोटॉन के रूप में रिलीज होने को आसान बना देता है। कौन? Minus I effect of chlorine atom, and therefore increases the acidic strength of chloroethanoic acid. समझ आया?
यस सर। यस सर।
आगे देखो, मान लीजिए दो क्लोरीन एटम लग गए हैं, डाई क्लोरोइथेनोइक एसिड है। नाउ व्हाट विल हैपन, दोनों क्लोरीन माइनस आई इफेक्ट एक्सर्ट करेंगे, क्यूमुलेटिव माइनस आई इफेक्ट ऑपरेट होगा, और आप देखेंगे हाइड्रोजन और इजीली रिलीज होगा। मतलब डाई क्लोरोइथेनोइक एसिड विल बी मोर एसिडिक देन क्लोरोइथेनोइक एसिड, and trichloroethanoic acid will be in turn more acidic than dichloroethanoic acid. Clear हुआ सपना?
Yes sir.
Due to cumulative minus I effect, यानी दो ग्रुप हैं, दोनों का इफेक्ट ऐड हो जाए, of two chlorine atoms, chloroethanoic acid is more acidic than sorry, dichloroethanoic acid is more acidic than chloroethanoic acid. समझ आया डायग्राम?
Yes, sir.
Yes. In the same way, due to cumulative minus I effect of 3 chlorine atoms, trichloroethanoic acid is in turn more acidic than dichloroethanoic acid. समझ आया?
Yes, sir.
आगे देखिए, ड्यू टू मोर स्ट्रॉन्गर माइनस आई इफेक्ट नाइट्रोइथेनोइक एसिड इज मोर एसिडिक देन क्लोरोइथेनोइक एसिड। ध्यान दीजिए, यहाँ नाइट्रो ग्रुप लगा, यहाँ क्लोरो, कौन ज्यादा एसिडिक होगा?
नाइट्रो ग्रुप।
क्यों, क्या रीजन है? दोनों में माइनस आई इफेक्ट वाले ग्रुप हैं, बट नाइट्रो ग्रुप का माइनस आई इफेक्ट ज्यादा होता है एज कंपेयर टू क्लोरीन एटम। पढ़े थे आर्डर?
जी सर।
क्लियर हुआ?
यस सर।
ना एक और बड़ा ही खास है, स्टेबिलिटी ऑफ एल्काइल कार्बोनियम आयंस। एल्काइल कार्बोनियम आयंस के स्टेबिलिटी को भी हम डिसाइड कर सकते हैं किसके बेसिस पर?
इंडक्टिव इफेक्ट।
इंडक्टिव इफेक्ट के बेसिस पर उनके रिलेटिव स्टेबिलिटी को डिसाइड कर सकते हैं। बहुत ही इंपॉर्टेंट है, याद रखना है। जो भी कॉन्सिक्वेंसेस पढ़ रहे हो सब अपने आप में नीट का क्वेश्चन बनाते हैं, और इन सब का रिलेशन बचे हुए ऑर्गेनिक केमिस्ट्री से। ऐसा नहीं है कि ये सिर्फ यहीं तक सीमित है, इन सब का ओवरऑल ऑर्गेनिक केमिस्ट्री पर इफेक्ट देखने को मिलेगा। समझ आ रहा है? यस और नो सपना?
यस सर।
नाउ स्टेबिलिटी ऑफ एल्काइल कार्बोनियम आयंस, द ऑर्डर ऑफ स्टेबिलिटी ऑफ डिफरेंट एल्काइल कार्बोनियम आयंस इज एज अंडर। क्या ऑर्डर है? 3 डिग्रीज, ग्रेटर देन 2 डिग्रीज, ग्रेटर देन 1 डिग्रीज, ग्रेटर देन मिथाइल। रीजन देखो, here plus I effect of alkyl groups attached to the positively charged carbon atom causes dispersal of its positive charge and therefore increases the stability of alkyl carbonium ion. Thus, the greater the number of alkyl groups attached to the positively charged carbon, more is stability of alkyl carbonium ion. समझ में आया? कार्बोनियम आयन की स्टेबिलिटी किस पर डिपेंड करती है सपना? कार्बोनियम आयन की स्टेबिलिटी डिपेंड करती है डिसलोकेलाइजेशन ऑफ पॉजिटिव चार्ज पर। याद रही, पॉजिटिव चार्ज जितना ज्यादा डिसलोकेलाइज्ड होगा, जितना ज्यादा डिस्पर्स्ड होगा, ये सही वर्ड होगा, डिस्पर्स्ड होगा, जितना ज्यादा फैलेगा स्टेबिलिटी उतनी ज्यादा होगी। यस और नो?
यस सर।
अब आप देखेंगे कि जो प्लस आई इफेक्ट है, ये देखो, सपोज हम इथाइल कार्बोनियम आयन की बात कर रहे हैं, यहां पर मिथाइल ग्रुप प्लस आई इफेक्ट एक्सर्ट किया, CH3 और C के बीच के इलेक्ट्रॉन को किधर रिलीज किया? टुवर्ड्स कार्बन। तो नेचुरली ये कार्बन का जो प्लस चार्ज है थोड़ा ही सही, लेकिन इस कार्बन पर भी आ गया होगा। यस और नो?
यस सर।
तो क्या हुआ? इस चार्ज का डिस्पर्सल हुआ ना, चार्ज फैल गया। पहले इसी कार्बन पर, जैसे मिथाइल ग्रुप में मान लो यहाँ हाइड्रोजन होता तो इसी कार्बन पर लोकेलाइज्ड था। जैसे ही मिथाइल ग्रुप लगा, मिथाइल ग्रुप ने प्लस आई इफेक्ट एक्सर्ट किया, इस सीसी बॉन्ड के इलेक्ट्रॉन को ढकेला टुवर्ड्स कार्बन। इलेक्ट्रॉन चूंकि इस कार्बन के पास आए तो इसका प्लस चार्ज थोड़ा न्यूट्रलाइज हुआ, और उतना ही प्लस चार्ज इस कार्बन पर अपीयर हो जाएगा। समझ आया कि नहीं?
यस सर।
तो नेचुरली प्लस चार्ज का क्या हुआ? डिस्पर्सल हुआ। प्लस चार्ज का डिस्पर्सल कर रहा है कौन? मिथाइल ग्रुप या एल्काइल ग्रुप का प्लस आई इफेक्ट, तो नेचुरली स्टेबिलिटी को बढ़ाएगा। जितने ज्यादा एल्काइल ग्रुप लगे होंगे पॉजिटिवली चार्ज कार्बन से, उतनी ज्यादा स्टेबिलिटी होगी। इसमें 2 लगे हैं तो इससे कहीं ज्यादा स्टेबल ये होगा आइसोप्रोपाइल कार्बोनियम आयन, और उससे भी ज्यादा स्टेबल होगा टर्शियरी ब्यूटाइल। दिख रहा है 3 मिथाइल ग्रुप हैं, इस प्लस चार्ज को डिस्पर्स कर रहे हैं इनके ऊपर, इन तीनों कार्बन के ऊपर थोड़ा ही सही, लेकिन प्लस चार्ज आ जाएगा। समझ आ रहा है कि नहीं? तो चार्ज का क्या हो रहा है यहाँ पर? इस प्लस चार्ज का डिस्पर्सल हो रहा है। तो नेचुरली आप क्या देखेंगे? स्टेबिलिटी इंक्रीज होगी। जितने ज्यादा पॉजिटिवली चार्ज कार्बन पर जितने ज्यादा एल्काइल ग्रुप जुड़े होंगे, स्टेबिलिटी उतनी ज्यादा होगी रेस्पेक्टिव एल्काइल कार्बोनियम आयन। क्या लिखा है? फॉर एग्जाम्पल इथाइल दैट इज 1 डिग्री, आइसोप्रोपाइल 2 डिग्री एंड टर्शियरी ब्यूटाइल 3 डिग्री कार्बोनियम आयंस हैव फॉलोइंग ऑर्डर ऑफ देयर स्टेबिलिटी। समझ में आया? इनमें सबसे ज्यादा स्टेबल कौन है?
tertiary
टर्शियरी
butyl,
ब्यूटाइल, देन आइसोप्रोपाइल, देन इथाइल, और उससे भी कम स्टेबल कौन होगा? मिथाइल कार्बोनियम आयन। तो समझ आया सपना?
yes sir,
तो आज हमने क्या क्या पढ़ा? एक तो IUPAC नेमिंग में हमने कंपाउंड्स कंटेनिंग सिंगल फंक्शनल ग्रुप और पॉलीफंक्शनल ग्रुप की IUPAC नेमिंग पढ़ी, बॉन्ड लाइन नोटेशन पढ़ा, साथ में हमने इलेक्ट्रॉनिक डिस्प्लेसमेंट में इंडक्टिव इफेक्ट पढ़ा और इंडक्टिव इफेक्ट के कॉन्सिक्वेंसेस को भी कवर किया। ठीक है, अब नेक्स्ट लेक्चर में हम इंडक्टोमेरिक इफेक्ट, इलेक्ट्रोमेरिक इफेक्ट, हाइपर कंजुगेशन और मेसोमेरिक इफेक्ट, इन सबको एक साथ लेंगे कल के क्लास में। तो आपका ये जो GOC वाला इलेक्ट्रॉनिक डिस्प्लेसमेंट वाला पार्ट है वो खत्म हो जाएगा। उसके बाद सीधा सीधा हम लोग कुछ और पॉइंट्स लेंगे GOC के, लेकिन कल इसको कवर करेंगे। तो आज के लेक्चर को यहीं रोके।
yes sir,
क्लियर है?
yes sir,
बाकी हम नेक्स्ट लेक्चर में कवर करेंगे। ओके, कुछ ज्यादा तो नहीं हो रहा है। एक्चुअल में ये जो आफान एक स्टूडेंट आया था उसको कंप्लीट इंग्लिश में क्लास, तुम लोगों को दिक्कत तो नहीं जा रही इसमें सपना?
no sir,
कंप्लीट इंग्लिश।
yes sir,
एक्चुअल में साउथ इंडियंस जो है उनको थोड़ा सा हिंदी में प्रॉब्लम रहती है, तो हिंदी ज्यादा नहीं आती, तो इसके कारण अगर उनको प्योर इंग्लिश की क्लास ज्यादा प्रीफर करते हैं। ठीक है, इस कारण मैं हिंदी थोड़ा कम बोल रहा था, लेकिन उसको शायद कुछ काम है, क्लास से हट गया था, तो फिर मैंने इसको स्टार्ट कर दिया। ओके, तो आज की क्लास को हम यहीं रोकते हैं, बाकी हम नेक्स्ट लेक्चर में देखेंगे। नाउ यू कैन लीव।
thank you sir।